Welcome to Study Loop.
So in this problem, we are given the number of moles of a weak acid and with an unknown pKa, which is combined with a certain volume and concentration of a KOH solution, and the resulting solution was diluted to a certain volume. We are given the pH of the solution. We need to find the pK of the weak acid. So we can do that by finding or using the Henderson-Hasselbalch equation, where we'll have pH is equal to pKa plus log of the conjugate base concentration over the acid concentration. So here we know what things we know here. We know um, the pH value, which is given here. We need to find out the pKa value, and we know the number of moles of acid. We have to find the concentration of acid, and we have to find the concentration of the conjugate base. So if we find these two terms here, that means the base concentration and the acid concentration, as you know, the pH value, will be easily able to find the pKa value. So to know the concentrations, we have to set up the reaction equation. So if we consider the weak acid as HA and we are reacting with KOH, that means we are reacting with KOH, that means we are reacting with OH minus ion, and we are producing the conjugate base A minus and water. So we have to find the equilibrium concentration of the acid HA and its conjugate base A minus. So our initial concentration of the acid is 0. So the initial number of moles of the acid is 0.25 mole. We have to find the number of moles here first, and our initial hydroxide ion, what is the number of moles of OH minus, we have to find that. So we are given the concentration of the KOH. The concentration of the KOH or OH minus is given as 3 molar, and the volume of KOH is given as 10 milliliter or 0.010 liter. As you know that the number of moles of KOH or the OH minus ion will be simply the product of this and this. So number of moles of OH minus will be simply the product of 3 mole per liter times 0.010 liter, and it will be 0.03 mole. So this is the number of moles of OH minus. So we just put the number of moles of OH minus here, and initially we have 0 of the conjugate base, and then so after the reaction we will have this number of moles of base will react with the same number of moles of acid. That means after the reaction we will have the subtraction of 0.03 from the original number of moles of the acid, and we will have 0 mole of the hydroxide ion, and we have 0.03 mole of the conjugate base. So in the resultant solution, the number of moles of HA will be, or the acid will be 0.22. This is 0 and this is 0.03. Now this is our number of moles of the acid. We'll have to place it here, and this is our number of moles of the conjugate base. Now, as we know that although the formula is the base concentration over acid concentration, if the volume of the solution is same for the base and the acid, we can directly put the number of moles of base over the number of moles of acid in this formula. So here, as we have said, that we have diluted the solution to 1.5 liter. That means that is the volume for both the acid and the conjugate base. So you can directly put the number of moles of base over the number of moles of acid in this part of the equation, and we can find the value of pKa. So let's write or rewrite the Anderson-Hasselbalch equation. We have given the pH value as 3.85. We have to find the pKa value plus log of number of moles of the conjugate base, which is 0.03, over the number of moles of acid, which is 0.22. So just solving this equation, we can easily find the value of pKa, and the pKa value will come out as 4.72. So this is the pKa of the weak acid involved in this reaction.